Hello, class. Today we're in Chapter 1, Lesson number 6, and we're going to be discussing 0 and 1. And we're picking these two out in particular because there's certain, let's call them properties that we need to be aware of about these two particular numbers. Let's read here at the very top of the page. 0 is the first of 10 symbols, the digits, with which we're able to represent any of an infinitude of numbers. 0 is also the first of 10 numbers which we must represent. Yet 0, first of the digits, was the last to be invented, and 0, first of the numbers, was the last to be discovered. They may say, well, why? Well, let's read here. Although the Alexandrian astronomer Ptolemy used the symbol, which is like a circle there, a 0 or an O, and as an abbreviation of the word meaning nothing, and that's as a digit in his work, it is not until many centuries later that the idea of 0 as a number was accepted. Because numbers originated with counting, it does not seem natural to count with 0. It was not considered to be a number. The counting numbers, also called the natural numbers, begin with 1. So we look at the natural numbers, we're going to start with the number 1. Oh, let me get my little pen here. So we're going to write out natural numbers, and we know those would be starting with 1, then there's 2, then there's 3, and so on and so forth. Although 0 is never used in counting, it is sometimes used to answer the same question that counting numbers answer, the question of how many. The behavior of the number 0 in calculations differ from that of all other numbers in several basic ways. It is the only number, and pay very close attention, it is the only number that can be added to or subtracted from another number without changing that number. Okay, so if we simply did that math, we have a number, let's say number 3, right? And we added 0. Well, what do we get? Well, we get 0. Well, what if we subtracted 0? Well, I'm sorry. I just made a big mistake there. Didn't mean to write 0 there. Let me go back. Does not change the number. I was actually jumping ahead to multiplication. So 3 plus 0 is equal to 3. And the same here would be 3 minus 0 would also be equal to 3. So it does not change the number. Now, we're going to let 3 or any number be represented by the variable x. Okay, so therefore we would write this as x plus 0 is equal to x. Meaning that whatever number you put in for the value of x, when you add to 0, it would always equal the same value of x. And the same could actually be said of x minus 0. And that also would be equal to x. Okay. They also use the example of 0 plus x because we can write these this way. 0 plus x is equal to x. Now we cannot say the same with 0 minus x, okay? We have to be very careful here. And they don't point that out necessarily, but I want to point it out that you don't necessarily flip your addition, your subtraction the same way you do your addition. What happens if we tried this? Well, if we subtracted x from 0, we would actually have negative x, okay? So let's not assume that we can flip our terms in subtraction. We've already discussed that in the past, so that's why they only show you the one example there. Okay, so with that, let's move on. It is the only number that, regardless of what number is multiplied by, always gives the same result of 0. So this is where I was jumping ahead, and let's do multiplication. We have for every number x, well, let's start off with 3. Okay, 3 times 0, well, that would be equal to 0. Now, we can just simply say any number times 0 is going to be equal to 0. Okay, and turning over to page 34, if x is a counting number, such as 5, it is easy to see why 5 times 0 is equal to 0 plus 0 plus 0 plus 0 plus 0, which is equal to 0. So using our 3 as an example would have been 0 plus 0 plus 0. And we know that that's equal to 0. So we can see why any number that you multiply by 0 is always going to yield the same 0. The result would always be 0. Assuming that the product of two numbers does not depend on the order in which they are multiplied, it is also true that 0x is equal to 0. So we're just going to write this in algebraic form, let's say, where we're using a number next to the letter or the variable, and we're eliminating over here this little dot of the multiplication. So 0x, okay, that's not an O, that's a number 0, x is equal to 0. Strange as it may seem, it is easy to divide 0 by another number. Yet dividing a number by 0 makes no sense at all. Okay, so we're going to have to explain this. Remember that the quotient of two numbers, x and y, which is x over y, is the number that must be multiplied by y to give x. So let's go ahead and use an example. Okay, an example we have that they're giving us is 6 over 2, right? So we have 6 over 2, and we know that's equal to 3, right? So we know that 3 times 2 is equal to 6. In other words, the answer to this is what number would we multiply, all right, by the 2, the denominator, okay, would yield our numerator. I know we're using different terminology, but basically that's the connection here. 6 divided by 2 is equal to 3, and 3 times 2 is equal to 6. So now dividing 0 by another number is okay. Let's go ahead and do that. We have 0 over x, all right? And we've been using the x times 0. Well, that would be equal to 0, right? Those 0x's, or 0x's, because we'd have to add the th, let's say, because we have observed that x times 0 is equal to 0. So we're using the same train of thought, how we're dealing with our quotient and how we can turn that into multiplication. We talked about how they're sort of cousins. And so now what happens when we try to divide by 0? Okay, something's going to happen and it's not going to be good because it's not going to make a whole lot of sense. Let's go ahead and just remove some of this and give ourselves a little bit more room. And if we try dividing 3 by 0, well, let's go ahead and do that. 3 divided by 0. Okay. The number 3 divided by 0 would be the number that must be multiplied by 0 to give 3. Okay, so what number could we multiply by 0 to get 3? And the answer is there is no number, because every time you multiply by 0, you're going to get 0. So we cannot use the same, and let's go back and just put the 6 over 2 is equal to 3, and we know that we multiplied these two terms to get 6, right? Those two turned into 6. Well, what number could I multiply by 0 to turn into 3? Well, none. It's impossible. So dividing 0, no, let's just say we cannot divide by 0. But now here's another particular type of problem that we have with 0, and it has to do with dividing 0 by itself. Okay, we'll try to be as thorough as possible with math, and the 0 does create some complications, especially when we divide 0 by 0. Now it gets a little bit tricky, doesn't it? Because we could say, well, let's see. Dividing 0 by itself leads to a trouble of a different sort. Suppose that 0 over 0, or 0 divided by 0, is equal to some number x. So we're going to say that's equal to x, right? Now, then it must be true that that x times 0 is equal to 0. And it does. It does work, doesn't it? Let's see. So we're going to multiply x, and that's actually going to come out to 0. Hey, that works. But this is true for every number, wouldn't it? Okay, well, let's pick a number. I'm going to pick the number 3. And is 0 divided by 0 equal to 3? Well, I could multiply 3 times 0, and that would be 0. So does this does it make any type of sense? No. In math, we say it does not make sense, and it cannot mean anything because it is meaningless. You can put any number. 0 divided by 0 can be any number. So that there's no meaning, there's no definition to 0 divided by 0. And again, we can just simply go back when we discuss dividing by 0 in itself is meaningless. It cannot be done. We don't divide by 0 because we cannot when we were showing the previous example, we cannot find any number that we multiply by 0 that would yield the number, as we were showing before. So we take 3 divided by 0. Okay, what number would that be? Well, anything we multiply here would never equal this. So we're just saying that even though you can look at this and say, yes, we can do that multiplication, it's meaningless. The number 1, on the other hand, plays the same role in multiplication and division that the number 0 plays in addition and subtraction. Okay, it does not change the number that it is multiplying or dividing. So let's go ahead and make a little room here. Let's go back and use a few examples, or at least we'll use the x and we'll use a number. So we have, they're telling us that for every number x times 1 is equal to x. And they use the 1x. Okay, you see we have the number 1 times x, and that's going to be equal to x. Okay, and we can also divide by 1, and it will also yield x. And let's go ahead and just use some examples. What would be 3 times 1? Well, that's going to be equal to 3. And what would 3 divided by 1 be? Well, that would equal to 3. So you can put in any number there, and that would always work. So we can see how 0 and 1 play a special role in math, and we need to be very careful with our zeros. Most importantly with the zeros, understanding that we cannot divide by 0, but it's going to be very useful to use the property, in a sense, if we want to call it that, of 0, because it will help us further down the road to solve some problems when we do have some things that are missing that don't exist, and we can represent them by the number 0. But again, we'll learn about that much later.